Okay, so these are the last set of notes for Chapter 6. This is 6.6, which is Properties of Kites and Trapezoids. So let's go ahead and look at this problem right here. So it says Lucy is framing a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters, 1 that measures 30 centimeters, and 2 that measure 27 centimeters. To complete the kite, she needs a dowel to place along KL. So we're looking for the dowel that's going to run on this main diagonal right here. She has a dowel that is 36 centimeters long. About how much wood would she have left after cutting the last dowel? So notice, guys, right here that it does say about how much. So you know that since this is a word problem, we're going to be able to use decimals in our answers. We're not going to have to use roots, but I'm going to show you both. The diagram here is already labeled for us. You can see that we have our 18 centimeter dowels there, our 27 centimeter dowels here, and the 30 centimeter dowel is this one right here. So what you're supposed to already know about kites is that these diagonals are perpendicular. So since they're perpendicular, we know that we have 4 right triangles, which should kind of tell you that you should be using Pythagorean Theorem. So what we already know, or what you should know, is that if this dowel is 30 centimeters long, this one that runs between J and M, you know that J to the center here and from the center over to M, that those are supposed to be equal, they're congruent. So if I do 30 divided by 2, that will give me these 2 sides, which are 15 centimeters. So I'm going to go ahead and label that. So now I have 2 right triangles right here that are congruent, and I need to know this side right here. So I'm going to use Pythagorean Theorem. So I know that if I do 18 squared minus 15 squared, then that will give me this side that I'm looking for. That'll give me a squared. So I'm going to square 18, and I'm going to get 324. I'm going to square 15 and get 225, and I'm going to subtract those, and when I do that, I get 99. And then to undo a square, I'm going to take the square root. Now, you are going to be able to use decimals, but I'm going to use roots right now. So I know that 99 is 9 times 11, and 9 is a perfect square, so the 3 comes out, and 11 stays under. So that would be the distance from K to, that's this distance right here. Okay, so now, if you notice, you have 2 right triangles here that are also congruent. So I'm going to use Pythagorean Theorem to find the rest of that diagonal. So I know that I'm going to do 27 squared minus 15 squared, and that should give me my missing measurement. 27 squared is, let me get my calculator, 27 squared is 729, minus 15 squared, which is 225. I'm going to subtract, and when I do that, I get 504, and I'm going to take the square root. Now 504 is a little trickier, but I told you guys that if the sum of the digits is divisible by 9, the number is divisible by 9, and 5 and 4 is 9. So if I divide that by 9, I see that it is 504 divided by 9 is 56, and then 56 has a 4 inside of it. So I know that can be broken down into 36 and 14. So this is, let me get a pencil, is 6 square roots of 14. Now, you wouldn't have to do that. You could have just taken the square root of 99 and added it to the square root of 504 on your calculator to get your approximation, but I know that some of you are still struggling with simplifying your roots, so I wanted to show you that. So now I'm just doing, in my calculator, I'm taking the 3 square roots of 11 and 6 square roots of 14, and I'm adding those together. And when I do that, I'm getting approximately 32.4 centimeters. But if I go back up here to my problem, I want to know how much wood I'm going to have left. So they need 32.4 centimeters for this entire diagonal. So if I take 32.4 and I'm going to subtract it from 36. So I'm doing 36 minus 32.4 to find out how much I would have left. And when I do that, I get about 3.6 centimeters left. So this is actually my answer. Okay? All right, so let's go ahead and look at the next one. All right, so now let's look at another problem. So here they're telling me that we have a kite ABCD and the measure of angle DAB is 54. So I'm going to go ahead and label that first. So I know that DAB, so this entire angle right here, is 54 degrees. Okay? Then I know that the measure of CDF, so this one right here, is 52 degrees. They're asking us to find the measure of BCD, ABC, and FDA. Okay, so let's think about what we know so far. So if I'm looking for the measure of BCD, so BCD, right here, you need to think about what you already know about a kite. So what you're supposed to know is that in a kite, consecutive sides are congruent. So this side and this side are congruent. Well, if those are congruent, then what that tells me is that this triangle right here is isosceles because it has two congruent sides. And in an isosceles triangle, you know that the base angles, so this angle right here, which we know is already 52 degrees, and this angle also have to be congruent. So now I have found that that angle right there also has to be 52 degrees. So what that allows me to do is find BCD, because now I have two of the three angles of that triangle. So we know that the sum of the angles in a triangle is 180 degrees. So what I'm going to do to find BCD, I'm going to do my work up here, I'm going to take 52 and 52 and add them together. So I know I'm coming off of 180. So 52 and 52, is 104, and I'm going to subtract that from 180, and I'm going to get 76 degrees, which is the measure of angle BCD, because I'm looking for that entire angle. So I know this one is 76 degrees. Okay, so what I'm actually going to do now is I'm actually going to kind of solve C rather than B. So what you should notice here, if you didn't know already, the main diagonal of a kite bisects these two angles, okay? And the reason that I know that is because, well, there's a couple of things I can do. First of all, I know that this triangle right here and this triangle right here are congruent. I know that these two sides are congruent, and then they have 90-degree angles, and then they share this side, so it's congruent to itself. So those are congruent by side, angle, side. So what that tells me is that these two angles have to be congruent. So can't I just take 54 and divide by 2 to find out the measure of each of those angles? So if I do that, I know, so I'm doing 54 divided by 2, and that gives me 27 degrees. That's the measure of FAD, and that's the measure of angle FAB. Okay, so I actually just found that angle, like each side, I just bisected angle BAD. Okay, now the reason that I wanted to do that is because if I know that this one right here is 27 degrees, and I already know that this angle right here is 90 degrees, then I can find this angle, okay? Or vice versa, because I'm actually trying to find, yeah, that's right, FDA. So I'm going to do 180 degrees, and I'm going to subtract off the 27 plus 90. So I'm doing the 27 and then the 90 right there. So 27 plus 90 is 117. And when I take that off, I find out that the measure of FDA had to be 63 degrees. So this angle right here is 63 degrees. Now, so far we've pretty much found everything we need, because in a kite, you know that there's one set of angles that are congruent. So I know this angle right here and this angle right here, those have to be the same. So since I know this is 52 and 63, I can just add those together. 52 plus 63 is going to be 115 degrees, and that would be the measure of angle ABC, which that's what it asked me to find. So I didn't go in this order. I kind of moved around and did A, then C, then B, because I used the information from C, but it's kind of a domino effect. Once you start breaking these into triangles and using your triangle rules, knowing these are isosceles, and then knowing your rules about kites as well, then you should be able to find all of the angles. Okay, so this problem is a lot less work than the last one. So when you look at this, what you should see is that this is an isosceles trapezoid. So I know that it's isosceles because the legs right here are congruent, and then I have one set of parallel sides. So if you know that you have one set of parallel sides, so I'm going to extend this out so you guys can kind of see it. If I extend out those parallel lines, do you see that it is being cut by a transversal? And what you should know is that these would be same side interior angles, okay? I know that those are same side interior angles, which allows me to find the measure of angle B, okay? So since they're same side interior, I know that they must be supplementary. So if I do 180 minus 100, then that tells me that the measure of angle B had to be 80 degrees. If that one is 80 degrees, then I know that in an isosceles trapezoid that the base angles are also congruent. So that means that angle A, which is the one that I'm trying to find, must also be 80 degrees. Okay, on this problem, what you should see is that you have another isosceles trapezoid. So because of that, I know that these segments are supposed to be congruent. Now notice what they gave me here is they gave me the distance from K to B, so I know that that is 21.9, and then they gave me from F to M, that entire segment is 32.7. Now I'm actually trying to find FB, so I'm trying to find this part of this long segment that I already know is 32.7. So the first thing that you're supposed to know is you are supposed to know that because KJ is congruent to segment FM, I know that because it's an isosceles trapezoid, and I know that those diagonals are congruent. I can then say that KJ is equal to FM by the definition of congruent segments. Okay. Now, okay, so from there, I know that if KJ is equal to FM, then I also know that KJ has to equal, where am I? 32.7, because that was given to me. Okay, so that was given up here in the problem. MF is 32.7. So if I know that the whole thing from K to J has to be equal from M to F, then I know that it's 32.7. That's how I know that they're congruent. So at that point, what you can do is you can use your segment addition postulate, like sub in everything. Okay, so I know that from K to B plus B to J has to be equal to the entire segment, right? The segment addition postulate tells me that. So now I'm just going to sub in my numbers. So what do I know? Well, I know that KB is 21.9. That was given to me up here in my problem. I don't know the distance from B to J, but I do know that KJ is equal to 32.7. Okay, so that's just your substitution. Now I can solve for BJ by subtracting 21.9 from 32.7. So I know that BJ has to be equal to 10.8. Now it kind of seems like a long way to get to that point, but it's important that you understand the steps, okay? So then from that point, now here's where things get a little tricky. So what you guys need to understand is that this right here, this FJ, or JF, depending on how you look at it, we know that that is part of a triangle. See these overlapping triangles right here, and then there's this one right here? I need to prove that those are congruent triangles. So I know that this base would be shared by both. So FJ and JF, that's the same line, so they're congruent, or it's congruent to itself. Then I know that angle KFJ and angle MJF, those have to be congruent because in an isosceles trapezoid, your base angles are congruent. So I've proven that this is congruent to itself and that these two angles are congruent also. Then I know that KF and MJ are also congruent. It's marked here for me. So then that tells me that these are congruent by side angle side. Now what that allows me to do is to say that these little parts right here is what I'm trying to prove that they're congruent. So I know that angle B, so BKF and BMJ, those have to be congruent by CPCTC because I just proved that those triangles are congruent. Now from there, I know that angle FBK and JBM have to be congruent. So these right here, they're vertical angles, so they also have to be congruent. So from there, I can say that KF, so KF and MJ, we already said that those are congruent, so that tells me that FBK and JBM, so these smaller triangles, taking this one out, so I'm no longer overlapping them, also have to be congruent by angle side, which tells me that these little parts from F to B and J to B have to be congruent by CPCTC. So that's what allows me to say that BJ is 10.8, which also means that FB is 10.8. That was a really long explanation to say that if the whole line is congruent to the whole line, then the part is congruent to the part. Okay? All right. Let's look at another one. Okay. So I think what I want you to do is I want you to pause and see if you can do this example on your own. It's a lot easier than the last one if you know your rules of isosceles trapezoids. Okay, so hopefully this one was easy for you guys. What you should have seen is that you have this trapezoid and they're asking us to make it isosceles. So in an isosceles trapezoid, the base angles are supposed to be equal. So what I did is I set a squared plus 27 and 2a squared minus 54. I set those equal to one another, and I'm solving for a. Okay, when I get down here, I'm going to take the square root of 81 in order to find the value of a. So I know that a could be plus or minus 9 in order for that to be isosceles. That would make those angles congruent. Okay, so see if you can now find the value of x so that a, b, c, d would also be isosceles. So go ahead and pause and try this one. Okay, so for this one, if you think back to that big old long problem I just did for you guys, sorry about that, you guys know that these are supposed to be congruent. So I knew that AD was 12x minus 11 and BC was 9x minus 2. So I set those equal to one another and I solved for x. And so if the value of x was 3, then this would be isosceles. Okay, so now we have a problem where we are using the trapezoid mid-segment theorem. So if we look here, what you're supposed to know, that theorem says that the mid-segment, which that would be EF in this case, if I add the bases together, the lengths of the bases, and I multiply it by a half or divide by 2, then that'll give me the length of this mid-segment. So to set this problem up, I know that 8 plus 13.5, and then if I take that and divide that by 2, then that will give me the length of EF. So 13.5, plus 8 is 21.5. And then 21.5 divided by 2 is 10.75. So that would be the length of EF. Okay? And that's using the trapezoid mid-segment theorem. Okay, so this is an application problem using like the algebra. So the first thing that I need for you guys to do is I do need you to change these amounts. So we want to find EF whose value is n plus 6. Then I know that AD is going to be n plus 3 and BC is going to be 3n minus 5. So once you make those changes, go ahead and pause the video and see if you can apply the mid-segment theorem, the trapezoid mid-segment theorem, using these expressions. Okay, so I set this problem up the same way that I set up the last one, only instead of having numbers, I have algebraic expressions. So I am going to add AD, the length of AD was n plus 3, plus the length of BC, which is 3n minus 5. So the first thing I did was I combined like terms and got 4n, and then 3 and negative 5 made negative 2. And I know I need half of that, so I'm dividing that expression by 2. And I set it equal to the mid-segment, which is n plus 6. Then once I divide by 2, I know that that expression becomes 2n minus 1, and then I just do my math to solve for n, and n is 7. Now be careful, make sure you actually answer the question that is being asked, and it was to find EF. So I had to take 7 and substitute it back into that expression that I gave you. So 7 plus 6 would be 13. And that would actually be the distance between E and F. All right, you guys, we will practice more of this in class. If you have questions, make sure you notated them in the margin. And don't forget to write your summary for tonight. Have a great night.